And to introduce our co-presenters here, we have 4 community helpers available today. We have Ohad Idan, who is my co-leader of the New York City Course.com developer user group. We have Shiv, who is one of my fellow MVPs, as well as Jonathan Baltz, also a fellow MVP, and Thomas Taylor helping us out as well. So we will all be available by chat throughout the meeting. And so any questions you have during the first presentation phase, go ahead and chat those to us, and we'll try to get an answer back to you promptly. And then a little bit later, when we get to the hands-on coding section, we will also have a means of assisting you with your code that I'll be covering in a minute. So I'm going to go ahead and get everybody muted here so we don't hear too much background noise of keyboards clicking and dinners being eaten.
The conference has been muted.
And now let me just get our presenters here able to join in. Jonathan, are you there?
I'm here. Hello.
All right. Why don't you go ahead and introduce yourself?
Hello, my name is Jonathan Baltz. I am a Salesforce developer. I've been a Salesforce developer for about the last 5 or 6 years. I currently work at a interactive law firm called Upright Law in Chicago. I'm also the organizer for the Chicago Salesforce Developer Group and a Salesforce MVP.
Great. Thank you very much, Jonathan. And next up, we have Ohad. Ohad, why don't you go ahead and give yourself an introduction? Aha, looks like our test of Ohad is not working. We'll come back. Shiv, why don't you go ahead and introduce yourself?
Sure, thanks, Luke. Hey, everybody, I'm Shiv. I run my own consulting firm called DaysWorks. I'm a Salesforce and a Course.com MVP, and I've been a developer for more than 6 years, and I run 4 developer groups in India. I'm glad to be part of this today. Thank you for inviting me.
Oh, thank you for joining. We're glad to have you. Let's see. Ohad, I see a text message from Ohad saying that asking if he could hear me, and no, Ohad, we cannot hear you. I'll double check and make sure you're unmuted here. Thanks everyone else for persisting while we get through some of the pre-game arrangements here. And Thomas Taylor, why don't you go ahead and introduce yourself? Let's see if we can hear you.
Can you hear me now?
Hey, there's Ohad. Great. Yes, I can hear you now. Go ahead and introduce yourself while we get Thomas online here.
Thank you. Sorry about this, some technical difficulties. My name is Ohad Idan. I have been Salesforce admin and developer since 2011. I've been active on the community and helping Luke co-lead the developer user group in New York City for the last couple of years. I currently work for a small company in New Jersey called ID Systems, where we use Salesforce very extensively to run the business, but very excited to get this workshop going back on.
And we are glad to have you back here. Ohad has been keeping me honest through the previous Apex workshops because sometimes I will wander a little out of my area of expertise, and we can always rely on Ohad to call me out on that. All right, so just trying to get Tom Taylor in here. I can see he is signed in, but I haven't been able to get him unmuted. So I guess at this point, I don't want to take up anyone else's time, and we will just have to hear from Thomas in the chat session. All right.
Here we go. I unmuted myself real quick. I found my number there. Looks like this is Thomas Taylor. I'm a senior support engineer. Yeah, I'm a senior support engineer with Round Corner, which working on our enterprise fundraising application for nonprofits. I'm a relatively have relatively recently marched the path from admin to declarative developer to code developer. So glad to be joining you on that same path this evening and over the next few weeks.
Great. Well, thank you to all the moderators for joining today. And let's go ahead and get started here. All right, so tonight we are talking about data types. And our data types, before I do that, I want to encourage everybody, if you haven't already, you should get a developer edition org because that's what we'll be working from tonight. I'm going to go ahead and post the developer edition sign up in the chat so that everybody who hasn't got one can go ahead and get started signing that up. Only takes a couple minutes. You can have as many of them as you like. And I do suggest continuing to use the same one throughout the Apex workshop webinar. I make sure that none of the code that we work on conflicts with other code. And this way you'll have a resource that you can turn back to when you need to try and evolve your own code. So I just posted that in the chat. That's the developer.salesforce.com link. And I'll also go ahead and post a link to the worksheet, which is an Apex test method that we'll be working on once we get to the hands-on section. And there that is. That is also in the chat. All right, so I guess I should introduce myself for those of you who don't know me. My name is Luke Kashanik. I work as a senior Salesforce developer for 2U.com, where I have grown into the role more of architect through many years, working with our 25 unlimited edition orgs. And as I started learning Apex about 5 or 6 years ago, I got so much help from the community that I wanted to start giving back to that community. And after spending a lot of time in the forums, answering questions, and starting to attend the user groups, I volunteered to lead the New York City user group, which I've been doing for about the past 4 years. And as a result from doing that, I realized there's a lot of people who want to follow that same admin to developer path that I trod, and that there were a lot of lessons to be learned that I could pass along. And that's how we got to the Apex workshops that you'll be enjoying over the next couple of months. So tonight's workshop is about data types. Data types are the most basic building block of our code. And you're probably already pretty familiar with them if you are a Salesforce admin or even if you're just an end user, because every one of those fields that you create or fill in boils down to a data type on the back end. And we'll be looking at how those fields that we use in the declarative interface relate to the data types that we use in Apex, and getting some hands-on practice with them. And when we get to the hands-on practice, we're going to try a collaborative editing tool. I'm going to go ahead and switch on my screen control here, or my screen share here, so that you can all see what I'm talking about. Hopefully I'll get the right one here because I've got 3 monitors in front of me. Let's see what comes up. If I got that right, you should be looking at a Force.com homepage.
We do not.
We do not.
See your desktop.
You see my desktop. All right, I guessed the wrong monitor. All right, let's try this one. Okay.
There we go.
All right. So we want to be able to help you during the hands-on with any coding questions you have. And the most effective way I've found for doing that is with a handy website called collabedit.com. And all you need to do if you need some help with your code is go to this page, click the big orange Create a New Document button, and then you can copy in your code. I'll give a sample here. Let me grab our worksheet from tonight. You can just paste that in, and then just go ahead and copy the URL and chat that to us in the chat room. And when somebody else picks up that URL, they will be able to collaborate. In fact, I'll even go ahead and throw that into our chat here. And if anyone wants to try out and see what happens when we do that, I should start seeing some collaborators hopping in there. So this is a collaborative interface.
That weird name is me.
Aha, I see a couple people. Yes, and then one handy thing, we can actually switch this to Java, which is the basis of Apex, and you'll actually get some nice syntax highlighting to make it a little easier to read. So each of the moderators will be available to help you if you get stuck in the code, if something is not, or if it's throwing an error or your test won't run, they'll be able to give you a little bit of assistance and help figure that out. You will need to copy the code back into your developer console. Unfortunately, developer console is not collaborative yet, so this is how we'll be working with this tonight. All right, so let's get on with data types. So while we are working through data types, there's also a couple other things besides just learning the language that are really important for you to be absorbing. Certainly the code practice where you get to correct these unit tests and get some practice writing Apex is the most important, but also getting familiar with the developer console as a tool is really essential so that you can work quickly. So you'll have a chance to run unit tests, and you'll have a chance to use the debug logs and be able to see that normal workflow that goes around developing an Apex. Another essential aspect that we'll be exploring is using the official Apex documentation, so how to read the various documents, which ones are essential, and how to decode the examples that they give there so that you can use that as a resource. And trust me, at all levels of development, you will be going there and reading through that and interpreting it and improving your own code. Additionally, beyond the Apex documentation, there's also the entire World Wide Web and lots of other Apex developers out there, and you're going to see a lot of different styles of code. Some people comment really helpfully, others never comment at all. Some people like to be very verbose in their coding and have a lot of very detailed steps, and others like to try and fit everything on as few lines as possible. So as you start running across other people's code out there, learning how to interpret that and how to recognize different ways of doing the same thing becomes really essential. So we'll be looking at some of the perhaps less common means of writing an Apex, so that if you see it, you can go, oh, I've seen that before. I kind of know what that is, and you can follow up and sort of reverse engineer it so that you can use it in your own code. And so with that introduction of all the things we're trying to learn here tonight, let's roll it back and get started learning our primitive data types. So Ohad has volunteered to take us through the list of primitive data types. Ohad, do you want me to keep this on my screen, or would you like to have screen control?
You can keep it on your screen if you'd like.
All right.
You can keep it on your screen and scroll down as we go. So what are really primitive data types? When you think about computers, you know that data is always stored somewhere. In order for a computer to manage effectively what we save, it really needs to know what kind of data you want to save. So if you think about your Salesforce fields, whenever you go into an object and you look at a field, you can see that a field is a checkbox field or date field or text field or all these other types of fields that we have. And that basically tells Salesforce what we are going to use this field for, what type of information we are going to save in that field. When you look at a database or writing Apex code or really any code in any programming language, you also have the same type of definition. When you create objects or tables in the database, or when you define variables that you can use in your program, you really have to tell the computer what type of data you're going to put in there. Very, very similar to creating fields on an object. The types of fields or the types of data types that exist have slightly different names than what you may be familiar from the declarative side of Salesforce. And the names, as we will start going through them, are not anything that is unique to Salesforce or to Apex. It's standard data types that exist in any programming language. You may or may not know Apex programming language is actually a specific program language designed for Salesforce, but it is based on the Java programming language. So the same syntax and the same commands really kind of govern the Apex programming language. In any case, we'll start going through the different data types that exist in Apex. We call them primitive data types. That doesn't really mean anything bad. It just means that those are data types that are not anything that is specific to Salesforce. So there's a couple of data types in this list that we will go over in a second that we are going to skip. We're not going to really focus on them anytime in the near future, and so there's not a lot of value in going over them right now. But what I would like to do is, as we go through the different data types, I'd like to ask you guys to try and pay attention and think what field in a Salesforce object relies or matches this type of data type. Once you find out or have an idea what it matches, just type it in the chat, and of course we'll see who can come up with the answer first. And so the first type we're actually going to skip, and that's the blob type. If anybody has any specific and wants to know, of course you can read the page that we see on Luke's screen right now is the Salesforce Developer User Guide, user documents. So everything is available to you. You can just Google Salesforce primitive data types and you'll get to this page. So the first data type that we will look at is called a Boolean. And a Boolean is basically a data type that can only hold one simple value, true or false. It can't have any other text, any other definition, and it only can have this kind of value of true or false. Can anybody think what type of field in Salesforce can only hold? Well, I didn't even need to finish my sentence, but I see already the first person that answered was Curtis Witcher, sorry. And yes, the data type that, the field type that Boolean matches is the checkbox. Checkbox, when you check it, it either has a true value or a false value. If you ever wrote a formula or a validation rule, you already know very well that when you want to check if a checkbox is checked or not, you use the true or false definition. And so when we create a Boolean variable, it always will only have either a true or a false value. And to be honest, it can also be a null value. Now, what does a null value mean? Null value basically on any type of variable, when you create a variable or define a variable, it does not have any value assigned to it. Even with a Boolean variable, even though it can only have a true or false, you really have to define if it is true or false. Unlike in Salesforce page where you create a checkbox field, you basically always define which is the default value. And so when a new record is created by a user, it will always get that value So a checkbox that's created through a Salesforce page will always have a value of true or false. It cannot be null. But when you talk about programming, if you just define the variable, if you created a variable but you did not define if it's true or false, it actually has a null value, which means it has not been defined at all. Okay, the next one we're looking at is the date field. So it doesn't take a lot to understand here to guess what the date field is. We have a very similar field type in Salesforce. And a date field is designed to hold exactly that. You can only hold a date value in it. You're not going to be able to save any text or any number value in a date field. You will only be able to put a date field, a date value, I'm sorry, that of course is different also from date time. And so the next field type that we look at is date time. And again, not a very difficult concept to understand. Just like we have in Salesforce a field for date and a field for date time, so do we have in our data types. A date time holds, just like its name indicates, both a date and a specific time in that date. I think, Luke, you usually like to say something about this here. But we'll talk about the formatting of these fields in a couple minutes.
Yes, we will.
So, okay, so the next data type that we have is called a decimal. So before I even start going and explaining what a decimal is, can you guys guess what type of Salesforce field a decimal is? Curtis said currency. Any other guesses? Katie and William Martinez said number. And so really, yes, the right answer, and I'm sorry, Curtis, is a number field. I absolutely can understand why Curtis immediately thought currency when we say decimal, because we always think about currency fields as the ones where we generally always want to look at with decimals. But really, a currency field is really just a number field that Salesforce knows to assign a currency value as well to. It doesn't really have anything special beyond that. But yes, a decimal field is a number. It's a data type that is able to accept a number with a decimal value. So why is it important? When we define variables, when we create variables to use when we write a program in Apex, a trigger or a class or whatever it is, we have to define the right type of variable. And as we go through this list over the next couple of data types, it will become a little bit more clear. But if you define a decimal field, it always has to have or can have a decimal value, compared to some other types which also are number types but cannot hold a decimal value. So the next data type that we look at is a...
Before we jump on, I do want to point out that the documentation does uphold Curtis's guess and says currency fields are automatically assigned to the type decimal, as well as the number field. And I'm guessing, but I haven't actually experimented with it, I would guess the geolocation field might also be a decimal, since I know that the format of that is has multiple decimals in it usually. But I'd love to, if anyone does know better on that, certainly chime in and help educate us all. And so, you know, as we'll soon see, a lot of the fields we use in the declarative interface boil down to the same decimal type when we're talking about Apex. And Thomas Taylor also pointed out the percentage field it also can behave like a decimal. All right, back to you.
Right, so I take it back, then I stand corrected. So yes, a decimal data type really can hold any type of number that has a decimal. So a Salesforce field called of type currency is assigned a decimal data type, same as a number. So with that, Curtis, I take it back and I apologize. You were absolutely correct, just like Katie and William that said number. And with that, we'll go over to numbers, to double. So can anybody guess what type of field a double would match or would be equal to? Okay, I don't see any answers, and that's actually a very good.
Shiv gave us a good answer. Answered 2 questions at once, in fact.
Oh, look at that.
Shiv pointed out that geolocation is, in fact, a double field. So I was wrong. It's not a decimal. And now we know that it is a double.
Well, I feel like I'm making a little fool of myself, and today people are correcting me, so I appreciate all the feedback. But yeah, so a double field is used for geo, but really what is important to understand about the double is that it's a field that can hold a very, very, very large number. In fact, it can hold 2 to the power of 63 digits, which basically is a 64-bit number. That is also why it is used for geolocation, because geolocation has a very long sequence of numbers. Generally speaking, though, you will not be seeing any field that really equates to double. When you think about numbers or dates or booleans versus checkbox, a double is not something that you would really think to equate to a field. Of course, geolocation uses that as the data type in the back end, but it doesn't kind of naturally make us think of double. I just want to go back to something that I saw that, who said that? Shiv actually made a comment earlier that date usually reflects the locale of the user. So we talked about a date field, and what's important to understand about date field is when you save a date into Salesforce, it does not actually save your locale. It has what we call a Z value, which is basically, I think it's GMT or Universal Standard Time. And when you load your page, Salesforce actually knows your locale and will display on the screen what the time in Universal Time would mean in your time. So date times, generally when we work with them in the database, we don't, or from a program, we don't really need to be concerned about that because Salesforce will actually apply the time with the current user's time zone, or the date with the current user's time zone. But as far as the database is concerned, it's actually all in universal time. That's how it's saved. And we'll probably see that sometime, if not today, then in the near future. Luke, can you scroll a little to the left?
Yes, I can.
Thank you. Okay, the next type is an ID type. I don't think there's really a need to ask the question, what type field is an ID, but I will. What type of fields do you guys think use the ID type? So in Salesforce, we use IDs really to store lookup values. So every time you create a field that is a lookup field or a master detail field, the data type is an ID type. And ID types are actually something that are unique to Salesforce. Salesforce ID types are always 18 characters alphanumeric strings that are case sensitive. And so every single time that you work with record IDs, you really use the ID type. Now, when I say every single time, it's kind of incorrect actually, because you could actually use an ID value also as a string, which is basically a text. But yes, Salesforce does have a specific data type that is designed to store only IDs. And that is important because if you try to put anything that is not an ID into an ID field, it will not be accepted. If you try to put anything that is not an ID into a text field, it will be accepted. Okay. By the way, there's a note on the screen right under the ID example that you can use both the 15 and 18 characters when you work with an ID field. A little bit of extra knowledge in case you don't know. Salesforce has this concept of IDs. Every single record that you create in Salesforce has an ID, and an ID can be 15 or 18 characters. What does it mean when a field can be an ID can be a 15 or 18 characters? How can the same record have both an ID that is 15 and an ID that is 18? The reason Salesforce has both of these things is that an ID is in fact 15 characters. The actual unique value of any record in Salesforce is 15 characters. The problem is sometimes you create, let's say, a report that only uses the 15 characters and you export it to Excel and you try to work with that, I will caution you because the IDs are case sensitive, which means you could theoretically have two records of the same object, and both records will have IDs that are exactly identical, but one will have a capital letter and one will have a lowercase letter. When you do analysis in Excel, for example, and let's say you use VLOOKUPs or compares or whatever it is that you want to do, Excel doesn't know to use case-sensitive values in lookups. And for that reason, you can use, instead of the 15 characters, you can use the 18 character ID. Those last three digits are what we call a checksum. A checksum is some algorithmic value that gets generated from the values of the 15 characters. And that value will be unique for every combination of 15 characters that comes before it. And so a record that has the exact same 15 characters, but one has a lowercase t and one has an uppercase t, will get a different checksum. So it's important to understand what is the difference between the 15 and 18. You can always use the 15 or the 18. The last three characters really just make it unique and make that ID or less important to use to treat that ID as case sensitive. Okay. Let's look at the next record data type. So the next data type is called an integer. Can anybody think what field type an integer would equate to? Okay, Katie is saying number. You're kind of right. I guess this is kind of a trick question because we really don't have a field type in the Salesforce front declarative side that is equated to an integer. Even when you create a number field and you set the decimal value or decimal numbers to 0, the field type that is used is still a decimal type. But integers as variables or as data type can hold only whole numbers. They can hold a negative value, they can hold a positive value, but they cannot hold any decimal values. In fact, you can see on the screen what is the minimum and maximum values that an integer can hold. Because it's a 32-bit number, the highest number that it can hold is 2,147,483,648. And the same thing, -1 on the positive side. Just a quick trivia question. Does anybody know why you can get up to 648 on the negative side, but only 647 on the positive side? Okay, that's completely unrelated, but because everything in computer is a binary, we actually have one bit that is designated to indicate if the number is positive or negative. So a positive number gets that bit assigned, which takes one digit off from the count. But that's it. So integers are full numbers. A lot of times in Apex, you will find yourself using integers. They're very convenient, they're very simple, and when you want to count something, they're the perfect type of variable to use. There's really no need to use a decimal when you want to count something. And we'll talk a little bit in a moment about why you would choose to use one and not another. Okay, the next data type is long. So a long is also a type of a number variable, and we already see that from the front end you have a number field or a currency, and they're all kind of the same. They just have a number where you can define if you want to have decimals or not. But you see that when we look at the data types, we already saw we have decimal, we have double, we have integer, and we have long. All of these are variables that are used to store numbers. Why do we need so many different data types just for numbers? Well, there's actually a few reasons. First of all, the use case is important when you select. So like I said, when you want to count the number of records, you'll use an integer and not a decimal, because you can't have 1.5 records, for example. But beyond that, a lot of times when we program or when we write process flows, or even when we write Apex code, we don't really care a lot about memory usage. But when programming started on computers, every single one of these data types uses a different amount of memory in the computer, and it uses the memory differently. So when we choose which data type to use, there's some consideration into how we're going to use it. And also we generally want to use the type of data that uses the least amount of memory. Again, today it's not so much a consideration. Computers, servers, and of course Salesforce, which all runs in the cloud, as far as we're concerned, they almost have indefinite amount of memory. When you write a lot more complex, and I'm talking about intensive graphic programs, that's when you usually have to go back and start considering how much memory I'm using. But for our purpose, we generally don't care necessarily how much how much memory we're using. We just want to choose the one that really has the most, or the matches what our use case is. Okay. We're going to, the second data type we're going to use, so the first one was the blob, and we're also going to skip our object for now. And so right under the object, we have our string data type. So can anybody guess what field type equates to string? Okay, Jennifer is saying text, Erin Ryan is saying text, Rachel is saying text, and William Martinez says character. Bill, I'm disappointed. We don't have a character field. But yes, you guys are correct. String is really a text variable, right? It's a variable that is designed to store text. And in fact, Salesforce uses the string type variable for all of the type of the texts that we have. So if we look at the text area long, text area rich, are all using string data type on the back end. String data types can hold any really number of characters that we want. In fact, I'm sorry, they do have a limit, and I don't remember what it is. Okay, so string data types don't actually have a specific length limit, but they are governed by something called the heap size. And we'll take a look at that later. But as you can see on Luke's screen, heap size can be pretty large, but it's a different consideration. We're not really going to talk about heap size right now, unless, Luke, you feel it's the right time to bring it up. But generally speaking, strings have the capacity to hold very, very long amount of data. And just like I started saying, they can hold really any kind of character that you want to store in them. This is how we use rich text. So rich text is an example of a string that the only difference between it and a normal text, really, a text area or a long text area in Salesforce, is that Salesforce knows that a rich text area is going to include HTML code. And so when you see something that is, let's say, a bold text or has a color, as far as the database itself is concerned, it's really just text. But then we have the HTML tags that Salesforce knows to interpret and apply formatting to the text based on. So really, string can hold any type of character, but there are some limitations and some things that we need to consider. When you want to define a string, you have to start with a quote. So you open a quote, just like we can see on the screen right now. It's a string S equals open quote, and it's single quote, by the way. And then we have some text. So what happens if you want to have a text that has a quote in it? Can anybody guess? Okay, Rachel is saying backslash, Shiv is saying escape. Those are all correct answers. So we have, in programming, we have something called escaping strings. And that basically means that there are some special characters that we cannot put in a string, just type it in, because the program doesn't know if it means something other than just a character, like ending the string, or if it's actually supposed to be a quote character in the string. So we use the slash character to do something called escaping and telling the program, hey, this is actually still a character. Don't consider it as a special character. And we'll look at how this is used in a couple of minutes. Okay, the last data type that we need to look at is the time data type. So in the Salesforce user interface, we know that we have a date time and we know that we have a date. Can anybody guess what field type matches the time field? The time data type, sorry. Rachel, he was the first to answer. Aaron said date time as well. So again, a trick question. There's really no field type that equates to time. So Salesforce allows us to do date time, allows us to do date, but Salesforce does not have a field that allows us to save only time. And in fact, I don't know about you guys, but I had a lot of times when I wished that it did. But usually you end up finding workarounds when you want to do that from the front end. But from a programming perspective, you do have that ability to create a variable that stores time only without the date associated with it. Look, I think that kind of ends my part. Let me know if you want me to go over anything else.
All right. So before we jump on to the next topic, let's take a look at some of the fields that we can create that we didn't call out. Can anyone guess what type of field, what data type a phone number field is? And this could be a trick question. So again, like the currency field, the phone field is a field that Salesforce just knows how to format specifically, but really it's just a text field. Even though it's called a phone number, it's not the kind of numbers that you would add. You don't add 303 from Colorado and 212 from New York City and get some point in between them. So the phone number field, Salesforce just does some magic for us so that it gets formatted nicely so that our CTI integration can recognize a phone number as opposed to just a text field that might have a phone number in it. You've probably noticed that Salesforce will treat phone fields differently. Similarly, the email field is also a text field that, again, Salesforce knows how to do some extra magic for so that we can use that in our marketing or other communications. And the email field has the added benefit that Salesforce enforces a little bit of validation on it to make sure that it actually is an email address. It does pretty minimal validation. It really just checks for the @ symbol and a dot in the address. But it's something that, by virtue of them giving it to us, we don't have to do on the back end. Another field we didn't cover, the URL. Once again, we have just a text field, but one that Salesforce gives us some special capabilities with. And continuing our tour of it's all text fields, we have our pick lists and our multi-select pick lists. These also behave as text fields when we are working with them in Apex. And we get that nice feature in our interface where they behave a little differently. And once we take a look at how multi-select pick lists translate, you'll just see that all they do is put a semicolon between each of the pick list values. So it's on the back end, they're very easy to work with. In fact, I find multi-select pick lists to be completely disagreeable on the front end, but when dealing with them in Apex, they are really rather pleasant. Let's see, are there any others that we missed in here? I think we covered them all. Well, auto number up here at the top. Now, this one, I wondered if this actually is an integer field. I've never really tried to add to auto numbers. So if anyone has any experience trying that, I'd love to know. Shiv is saying it's a string. Was that in answer to the auto number question, Shiv? Aha. So the auto number is a string, one that I guess Salesforce knows enough to know that it can increment it each time as a number, but one that we could not actually do calculations with. Then we have the formula field, and as you probably all are familiar with, when you pick a formula field, the very next question is, what data type do you want it to be? And at that point, Salesforce will start to enforce some data type restrictions on your formula field. First, in the output from the formula that we calculate, it must obey the data types rules. But then also in Apex, when we're working with it, we have to treat it as that data type and manipulate it accordingly. And of course, as a read-only field, all we're ever doing with it in Apex is just using it to perhaps influence other fields or other controls that we are building into our Apex. All right, did I forget any fields here? Did we identify what every field that we can create in the interface becomes in Apex? I think we did.
I guess the only one we didn't really touch was the encrypted text. And so encrypted text is a little tricky because it really is nothing. There's nothing special about it. It's really, again, a text field, but Salesforce uses encryption to store the data, and in the database it's stored in as an encrypted value. So even if you had complete access to the database, without knowing how to decrypt the text, you would not be able to read it. But again, just another string.
All right, so that's enough about data types and fields. Let's look at some of the glue that holds them together. We're going to take a quick primer here on expression operators. Let me go ahead and get this back to full screen. So there are many of these, and really we're just concerned with a few that we're going to be using tonight. But this is where you want to go if you are looking at someone else's code and you see something like /equals, and you're thinking, are they trying to escape the equals sign? What's going on here? this is the page to turn to help you define just what it is that particular sequence of characters is doing. Now, the ones that we're going to see tonight, we're going to see a lot of equals. This is, at first, a little bit, you think, oh, well, I know what equals is. We're going to quickly see that there are some slight variations. You see it here is called an assignment operator. And what that literally means is it does the operation of assigning a value. So the syntax here is saying x equals y, but what it's really kind of translating to is assign the value of y to x. That is in comparison to, down here, the double equals. This is the one that we're probably all much more familiar with from our early education, where we say that two things equal each other. You'll start to see more of this as we get a little further into logic in future sessions. But a way I like to remember that the double equals is like an equality operator is I think of those other type of equality or comparison characters, like the greater and less than, and most particularly the less than or equal, or the greater than or equal. So I like to think of those in comparison to the double equal. And I think, oh, that's right, these are comparison. Less than or equal compares two things, and two equal signs is also comparing them, not assigning them.
So look, if I may interject for a quick second. So, I think everything that we talked about last week and today so far is very, very easy to relate to what you've already done as an administrator, right? We talked about data types, and you say, okay, I understand exactly what they are because I worked with fields. And really, this is kind of where we start to have some more distinction. Salesforce, what Salesforce does really great is it simplifies complex programming concept into mechanisms and tools that really anybody with zero programming experience can use. And that's why when you write a formula, you can use equal to compare. You can basically say in a formula field, if this field equals to that field, or if this number field equals 1, and you really just use one equal. But now as we get into programming, you'll notice that there's a lot more what we call syntax, how you write things, what's the right way to write things. And part of it is that the computer really needs to understand exactly what you're trying to do. And so just start thinking, as we start going through this, just take a moment and realize that what you're doing, what we're starting to look at now, this is really where it starts to depart and look a little different from what we do from the front end, from the declarative side.
And the great thing about declarative development as an admin, as you advance into writing Apex, is that you already get the concepts. You've already been creating data types left and right. You've already been creating logic in your formulas and your workflows. So conceptually, you have the tools you already need. Now you're just learning a translation of them into Apex. And a lot of it is very similar. So it's not a particularly big jump to start writing in Apex. A couple other operators that we will be seeing tonight are the increment objects. Again, we have this peculiar double character format of ++, and actually going back to our auto number conversation a couple minutes ago, this is a special type of operator that simply adds 1 to the value of x. And quickly becomes something you use a lot as you start writing your triggers. And similarly, there's a decrement operator that I can pretty honestly say I've never actually used. But hey, it's there, and you might just see it in someone else's code, and it's not simply a lazy way of creating an M dash. It actually has a function. And then, of course, the other ones that everyone is familiar with from writing formulas are some logic. We have the AND character, as well as the OR. And we've all seen these in our formula writing when we need to get that particular bit of logical operation. And just while we're on it, because sooner or later you'll be looking at someone else's code that'll have a very peculiar construction. That is, where is it here? The ternary operator, which is this strange pair. So unlike the other ones, this one has a space between it. And that does not mean you use it by typing a space. It simply is describing that this is a shorthand for creating an if-then statement. So just like in formulas where we say, if this condition is true, return one result, and if it's false, return another result. This is a shorthand way of saying for x, if x is true, and in this case, x might just be a Boolean or a checkbox. If it's true, return y, otherwise return z. So you'll see those type of developers who really like to condense all of their code into as few lines as possible using that particular operator. We'll eventually, a couple sessions down the line, get to practice with that. But if you're out there looking at Stack Exchange or developer forums, you might just run into that and wonder, what the heck is that? All right, so I think we've got the basic operators that we're going to be working with tonight covered, as well as a few bonus operators in there. Jimmy just asked a good question. Are ternary operators faster than longer logic? I would guess that they probably are. And the basis for that guess on my part is that there are some restrictions to what you can do with them. You can't put in extremely long, complex conditions, and I think it operates on only some data types and not all when you're building the condition. So that kind of tells me, all right, Salesforce has limited this in the Apex language, and that's probably so that it can function rapidly and not have to interpret a lot of detail. I could be completely wrong on that, but hey, I just wanted to try and answer it somehow. What do we have? Shiv has some answer here. Okay, there's a good answer. Shiv says they used to be effective when there was a limit on scripts, on how long your scripts could be. So this was also a way to sort of reduce the overall amount of code that was appearing and to get underneath some of the limits. And of course, as we start doing more Apex practice here, we'll start talking more about governor limits and some of the ways that we design and write our Apex to avoid those limits and make sure that our code runs in all conditions.
Yeah, and a couple of releases
Look,
back,
I just
that limit does not apply anymore. But yeah, it used to be like that. Sorry, go ahead.
Great, thank you for contributing that.
I was going to add, I just tried to Google, and you'll find if you Google, and I remember we did this also the same. I remember Googling exactly the same thing when we did the workshop class in New York City, and really there's no difference in terms of the processing speed, but it's kind of old school to write ternary, and some people really love using it. And if you start Googling, you'll find that there's some people with really strong opinions on whether we should use ternary or not. There's even some interesting arguments. But the reality, the bottom line is, if you're comfortable using ternary, you can use them. I think a good general rule of thumb is if it makes sense and if it's clear exactly what your ternary condition is doing, use it. Don't write just ternary because you can and you want to look cool, because the reality is if somebody else tries to read your code a month later, or if you're trying to read your code a month later, you might not be able to figure out what you did, or it might take you a long time to figure out what you did. So I think that, one of my guides is when I write code, always I try to make it as clear as possible. I make a lot of notes, and we'll talk about all that, but I only use ternary generally on relatively simple if then else conditions where it's really clear what it's doing. And that's all I have to say about that.
All right, let's start jumping into some coding here. I think we've covered enough lessons here. Let's actually get into our developer console and start working up to our worksheet. So back here in my Salesforce org, I'm going to pop open my developer console. And for starters, I'm going to be using the Execute Anonymous window to demonstrate some of the Apex concepts that appear in our worksheet. I'll go ahead and pop this open, and hey, it looks like I've already been doing some work in there recently. Let's make this a little bit larger here. All right. So one of the first things that I always do when I enter the anonymous Apex window, if I either resize it or this handy up arrow here is going to pop it open in a new window, and it will persist this window as I execute it. So we're going to start our discussion and our practice working with strings, because as we saw, the string underpins so many different field types in Salesforce that it is one of the most common fields that you end up working with, or data types that you end up working with. And a string you have to define as a variable. And so the first thing we have to do is we have to say, well, we're creating a string. So we have that there. This is a string. And then we have to give it a name. So I'm calling this variable my name. Now, we don't necessarily have to populate it with anything. We can just leave it at null by closing off our instantiation of that variable with a semicolon. And we can get around to populating it later. So in that case, I would say, because I've already created it, I can just refer to it as my name now. And because this is text, we do have to use our single quotes. And I can type those in and now close that off. And now on line 2, my name has been populated with that value. And then I can change that if I need to in the future simply by repeating that and giving it a different value. And so now we have just a very simple bit of code here that says I'm creating a string called my name. I'm assigning it the value of Luke. Now I'm assigning it the value of Lucas. And then our line 4, this is something we're going to use a lot tonight, is a debug statement. So if we were to execute this right now, it's really not going to go anywhere visible. It's not going to show up as a record in Salesforce that we can go look up. The only place that we can really take a look at what just happened is to go to our logs. And you could, of course, pick through the logs and try and find where this all happened. But the easiest way to see what's happening with your code is to use this system debug command and method. So system is the class, and debug is the method. We'll talk in a future session a little more, or a lot more, about classes and methods. But you can kind of think of them as similar to like the functions that we have when we are creating formulas or workflows. Certainly something like the isChanged function that we can use in a workflow is just ultimately a method. It's a method that is able to detect whether the value of a field has changed. And similar to formulas, those functions typically require us to put in an argument to tell that function what it's going to work on. So in this case, we're just going to say we want to debug my name, which means that it will return the value of my name when we execute this, which we're about to do. I'm going to go ahead and leave open log checked here because, hey, it saves me a click. And when I click execute, that runs, and back here in my developer console, it has automatically taken us to the log that was generated by that transaction. Now this is a nice short log, and it wouldn't be too hard for me to look through and go, oh, here's where I assign the variable. In fact, it even says so, variable assignment. Here's where I assigned it the value of Luke, and here's where I reassigned it the variable of Lucas. But if I really want to see, well, what is that value? The debug statement here has returned that value. And if this was a particularly long log, like most of them will end up being, I can also use this convenient debug only checkbox to limit it to only the debug lines and really start to look through very closely at what the value of a particular field or other data types is at a given point in the code. Now I say at a given point in the code because things change throughout your code. So if I were to copy this here, after I first assign it, and then use it again after I reassign it a value, I'm going to get two debug statements. And see, did it open that log yet? There it is. So now I've got both of those at the different times in the script as they changed.
Another quick thing to point out, you can see next to the word debug, we have a number in a square bracket. This, when you look at long logs, or even not necessarily log, that little number there can become very useful. All it tells you is what line number in your code this line represents, or what line number in your code generated this line in the code. In this case, we see the first debug is in line 3, and the second debug is in line 5. And of course, when Luke goes back to the anonymous code, we'll be able to see exactly that. The first debug was on line 3, and the second debug was on line 5.
And for even more convenience, one of the tricks that you'll see developers doing is adding some extra information to the debug output. Because once you start having a lot of debugs, they get a little hard to distinguish one from another. So I can actually just type in random text here, first assignment, and then I'll use a plus operator to essentially concatenate the my name string to this text that I'm adding here. And then so I can tell this apart from the second debug, I'll change this to second assignment. And because I really want this to stick out, I'm just going to string in a whole bunch of random characters. I'm choosing the greater than, but since this is a text string, you can use just about anything. And now when I execute this, even if I don't want to run through the debug and I just want to scroll through it, boy, that one really pops out. So this is just a simple shortcut that is commonly used by developers to really make their debugging a little easier. Now I said you can use just about any character, and I think this is a good chance to point out what Ohad was talking about earlier when he said sometimes we need to escape characters. So if I wanted to say this is my name's second assignment, as soon as I added that apostrophe in there, the compiler sees that as a single quote, and it thinks this is everything that is supposed to be my text. And then this, it's not going to know what to do with that. And if I were to try and execute this, it's going to throw an error. Line breaks not allowed in string literals. It's not the most friendly error message, but it pretty much means that you have some formatting problems in your string. And in this case, as we talked about earlier, the way to escape that apostrophe so that the compiler doesn't treat it like a single quote is with a backslash. As soon as I add that in there, the syntax highlighting returns this to one consistent color. And the compiler now knows ignore whatever follows this backslash and keep looking till you find an unescaped single quote. And so now we've been able to build that apostrophe into our string. And there's the apostrophe conveniently hanging out in front of the return from the variable my name. And notice that it did not try to interpret that variable in the string. It just treated that like any old text, not code, just text. So that is the very basic breakdown of how you assign a value to a string. And one thing that we saw when we were doing our debug is that we can also concatenate strings. Now we did that within our debug statement. We sort of created a string on the fly, and then we concatenated another string to it. But what if we want to concatenate two strings? So now we've got a second one here called your name, and let's assign a variable to that. And looking at the comments, the most recent comment was from Thomas. So Thomas, you have won the your name contest. So now we've got a second string. And if we wanted to concatenate two strings together, we can do that very simply by just referencing them like that with a plus between them. And that will, in the case of strings, it will just concatenate them.
Hey, Luke.
Yeah.
Thomas made a good point to us, to the rest of the presenters, and I kind of figured it's worth bringing it up. This is probably more for people that had any kind of experience programming in the past in any other programming language. So you've seen already that we use the system debug to get some kind of message out. And some of you may, if anybody here had an experience with programming, you may think, wait a second, I remember using something like print line or print or write or something like this to create an output. So when you write a program in something like, let's say, Visual Basic, and you want to present some message to the user, you can use something like print. But in Apex, all of your code does not actually render to the screen. We'll actually talk about that when we start to talk about Visualforce, which is the presentation side of Salesforce programming paradigm. But as far as Apex goes, you really don't have any way to present values to the user. Even system debug is not really designed to present as value to the user. all that it does, it tells Salesforce to put some information, some piece of information, whatever you put inside the parenthesis, in the log that the program generates. So again, it's not designed as a mechanism to show something to our users. It's really, and that's why, by the way, it's called debug, right? Debugging is the process by which programmers try to find errors in their code. And so this is exactly what you use it for. You use a debug statement usually to insert some value into your log, whether maybe you want to see, when you run the code, I want to know what value some variable has at this point after you've done some really complex calculations. And so you'll use system debug to expose it to the log so you can evaluate it. But it's absolutely not designed to provide information to the user that's going to use your code. I hope that was a good answer. Tom.
I think it was. As a self-taught Apex developer and one who never wrote any other language, I just accepted it as this is how I debug. But certainly if you're coming from another language, it is a bit of an oddity. All right, so we saw here.
Sorry there, Luke. Just all I wanted to mention, when you are going more into advanced Apex development, there's also something called simulated breakpoints, where you can put them onto the code and check for the variable values. But that's a bit more advanced in Apex. But yeah, I just wanted to make sure when you come across that, that's also a way you can check for variable values and stack trace.
Right. Yeah, the developer console has a lot of very advanced functionality hidden in its menus, so that you can really drill down into the code and do some of the things that developers are used to doing on other languages and directly on their servers. All right, so we're just about ready to start getting you writing some code here. So this is your last chance to get that developer edition signed up and get logged into it. Because in just a minute, I'm going to have you copy the test method worksheet into your developer console and start fixing some broken code, because that's something we do a lot of, or at least I do a lot of. All right, so we already saw that the debug is a method that will take an action and given an argument, given a value, do something with it. Well, there's a lot of methods that we like to apply, particularly to strings, so that we don't have to code every little change we want. So if I wanted to shout my name out, I can use a method, a string method called toUppercase. And I can see if I can get autocomplete. I'm not sure that autocomplete is going to kick in here in anonymous Apex. To uppercase. And when I do this with, let's see, I don't actually need to provide an argument. So we're seeing a second variation on how functions and methods work in Apex. And this is something we'll take a look at in the documentation in just a second. But in this case, I just need to tell it this variable and this function. And now if I do a system debug on my name, I didn't get it.
Well, that was kind of where you tricked yourself, I think. So what happens when you use a method like toUppercase, basically what you're doing is you're saying, take the string and convert it to an and give it to me as an uppercase. But at this point, you haven't actually made change to the string. So you can do one of two things. You can either do what Luke is just doing now and put it inside the debug statement. And basically what we're doing here is we're saying debug the uppercase version of my name. Or the other thing we can do, and if you want to do it in the next line 9, Luke.
Yes.
you can actually type my name equals my name dot to uppercase. And this way you're actually taking the uppercase version of my name and assigning it back to my name. So you're kind of rewriting the my name variable. And you didn't, I just wanted to do one more debug after 9, sorry.
Oh, okay. Well, I'm just going to skip over to the logs. I want to get us moving along here. So now if we do the debug, there we go. The debug on line 8 shows us that it did do uppercase. And then another useful thing, when you're using debug and you highlight a line, when you turn it off, it takes you right to that line and you can pick up from there. And here we can see line 9, my name was actually reassigned as uppercase. And were we to do a debug purely on my name, that's what we would get at this point. All right, is everyone ready to code? Let us close this, and we're going to start by creating an Apex class. So everybody open your developer consoles, and from the File drop-down menu, choose New Apex Class. At this point, you can call this Apex class pretty much anything. So I'll call this pretty much anything. And Salesforce does just a little bit of preparation. It automatically defines the class as a public class, puts its name in, and gives us the brackets between which all of our code must go. And since I wanted to get this to you in a nice, easy format, I'll go ahead and repaste the link to the GitHub gist that contains the code we're going to be working with here in the chat. So you can pop off to that screen. And let me drag that on screen here so you can follow the bouncing ball. So here we are looking at that page. And this has all the code for a test method that we're going to put in that class. Now I find the easiest way to cut and paste this is to click the raw button, because then I can simply do Command A to highlight everything and Command C to copy it all. Get rid of this and go back to my developer console. I'm going to put my cursor at line 2 and copy all of that in. And as you can see, it automatically starts to highlight the code in there. Now the one thing that we need to do, because this is a test method, we have to start the whole class with our @IsTest annotation. That's what tells the Apex compiler that everything in this class is going to be a test class. And I don't know if you noticed there was a little red exclamation point there. That was actually telling me that I have a test method, but I didn't define the annotation as @IsTest. As soon as I added that in, it said, all right, now you're good to go, so I'll go ahead and save this. And so we start with a few lines of examples here so that you'll have some text to work with. And some examples of the lessons we just covered, including the to uppercase. And as you scroll through this test method, you're going to find this fix me phrase here. And these are lines that somehow need to be altered to work and get the output that we are seeking. So we've got 3 in a row here, and I'm going to give you a few minutes here to work through these and try to get satisfy the instruction. So this first one on my line 16 says, turn text 4, this variable we have here, into a lowercase string. So now this one probably is pretty easy to guess. We saw to uppercase here. I'm guessing that most of you will pretty quickly interpret as, oh, well, this one should be to lowercase. But as we move on, you'll quickly see the definition is not as clear. And this is where our lesson also includes how you work with the Salesforce documentation. So in this, for this, you're probably going to start out Googling. So here I'm going to go off to Google. And I'm going to do Apex string methods. I don't know exactly what I want, but I know the documentation has it. And I get a long list of all sorts of functions, because these are just like the things we have in workflow that will make changes to the string. So you'll want to take a look through here for text as you get to text 6 and try and figure out how can you get rid of the white spaces that are in the text. So I'll let everybody take start taking a whack at those first 3 fix-me's for text 5, text 6, and text 7. And this is also the time that if you get stuck, you can copy your code into Collab Edit and pop that into the chat, and we will try and get your code back on track. And in about another minute or so, I'll start completing the code in the developer console. So if you are really lost, just wait 60 seconds and you won't be.
Luke, you can finally take a moment to breathe.
That's right, and take a sip of water. I'll go ahead and chat the URL for the string methods here. And I'll give just another minute here for you to hunt down the answers to those 3. And when you think you've got them, go ahead and click Save or Command-S or Control-S for Windows. And if you got it right, it'll save. If not, you're going to see something crop up in the problems. For example, if I have a bad variable name, when I try to save it, I'm going to get a message here that says that variable doesn't exist, and the line number on which the problem occurs.
So nobody's asking for help. That's great. That means you have done a magnificent job explaining it, and everybody's going through this very, very quickly and easily.
So once we have it saved, all that means is at this point the text will compile, or the code will compile. Doesn't necessarily mean that it's going to run and produce what we wanted. So the way that I set this up is that once you've saved it, we can use this run test, and that will run through the code, executing all of it. And we can use our logs to take a look at what we just did. And since we were creating system debug statements, I can click on the debug only and quickly start to get at the output. And I tried to give us some pointers in the debugs to tell us what to expect. So the first one that was done for you was when we did the to uppercase. So we shouted out that. And then the next one to lowercase, we're whispering it, and it should have returned it all to lowercase. And then the first one that required some research on your part was how to wipe out the white spaces. So for that, I use the delete white space function. And that appears here on our string methods here, and it tells us returns a version of the current string with all white space characters removed. If I click on that, it takes me down to a much more detailed description of what's going on there and shows me an example of how I would use that. And this is where I knew that I don't need to put anything in the parentheses. I just need to give it the variable name and then a dot for the dot notation, and then put in my function. We'll see some shortly that actually do require an argument. And then the final one, text 7, this was making sure that you all felt comfortable adding your variable name into the debug statement. So I had left this part out, and you needed to go in and first put in a plus to concatenate this string, which also has one of those escape characters in it, with our variable. And as Ohad said, we didn't see anything coming up, so it sounds like everybody got through that one painlessly. So let us move on. So as I said, some functions, like delete white space, don't require an argument. However, others do require an argument. Here on line 22, we use the remove method, and we had to tell it, what do we want to remove? Well, we want to remove the string text. And so when that executed, let's say that was line 22, and debug line 23, we can see that what previously was this text, that text, more text, just becomes this, that, more. And the next type of function or method that we're looking at here, this one actually takes two arguments. This is a replace statement. So this is your basic find and replace tool. And I'm able to provide it the first argument, which says find more in that string and replace it with the string less. And if we take a look over here, what we had previously was this, that, more, and now it's this, that, less. And if I don't lose my place here in my browser, we next move on to one that instead of taking a string, it's taking a number. And this particular method, repeat, will just repeat whatever variable we give it. And the number of times. And let's take a look at line 29. So it just doubled this, that, less, this, that, less. So when you're looking at the string methods, you're getting some extra information in each of these descriptions. What we saw here was for the delete white space, we have a return value, and that's saying, well, it's going to return a string. It starts with a string and returns a string. And so far, all of the ones that we've looked at up to this point do just that. But there are other types, and our next example uses length. And I think I'll just see if I can shortcut to this. Oh, there's 58 examples. All right. There's got to be a quicker way. I'm going to go back to the top here. Sorry for the...
you can just write length and open close parentheses.
Oh, that's a good idea. But I'm almost there. I'm feeling it. I'm feeling it. There. Oh, no. All right. Thank you, Ohad. This is why I so need Ohad here, to save you all from nauseating scrolling. What we see here is when we use length with a string, it's going to return an integer. And if we take a look back at our code, the next example takes text9 and uses that length method. But because it's going to return a number, we can no longer assign that return value to another string. Up till now, we've just been returning it to a series of new strings. Now we have to return that as an integer. And we know that because the documentation said the return type is an integer. And if we take a look at line 32 in our logs, we'll see that it's saying that string is 24 characters long. And so that's just going through and counting the total number of characters in there. But now we're going to get to a pretty important concept that we'll be returning to time and again, and that is called an index. As you can see, our next example here uses this phrase, index of. Now, the index is a concept in programming that doesn't refer necessarily to the length, but to the position of a particular element within another element. So if we wanted to know where in those 24 characters a particular phrase appears, we can use the index of, and in this case we're using the index of the string this. The important thing to remember about indexes is that they start with 0. So the character that's in the first place is at index 0. And our phrase, which I think at this point is something like this, that, less, starts with the word this. And so when we do an index of it, it tells us that this occurs at index 0. Now, it's not telling us all of the spaces that this takes up. It's not telling us that it takes up 0, 1, 2, and 3. It's just telling us where it starts.
This is probably a good point to talk a little bit about index 0.
Please do.
I don't know if you want to bring it up right now.
Go right ahead, Ohad. I could use a drink of water.
Why don't you do that? So, okay, when you talk about a program, any programming language really, when we look at indexing or location within a string or even within any kind of collection, and we'll talk about collections in the future, when we look to find the location of something, generally we use something called zero index, meaning that the first occurrence of whatever we're searching for is in location 0. So in the word this, T-H-I-S, if I want to know what is the letter in location 3, it's actually going to be the letter S because it's the 4th letter and we're starting to count from 0. So the same thing happens when we search where something where the word occurs. It is going to tell us the result with the first character being 0. That's all.
All right. So your next assignment for line 37 is to get the to add the method for text9 to find the string that in text9. And of course, you'll have to save that and run the test again. And when I debug this, it tells me that that occurs at index 4. We can actually see the string here, and we can see that if we count this out, we start with 0, 1, 2, 3, and the T in that occurs at index 4. Our next example is using another method that's last index of, which will tell us the last occurrence of that. But what we're really going to start doing with this particular set here is we're going to look at next system class method, and that is the assert equals method. So assert equals is a method that we use heavily in our unit testing. When we use this in a test, when the Apex compiler gets to that line and we execute the code, it's going to expect us to give it 2 values. First, it's going to ask us for an expected value. So I counted out where the last occurrence of that starts, and I found that it started at index 16. So that's what I expect it to be. But then I want to compare it to what it actually is. And so this is where I pull in my variable, number 4. And I now have my expected and my actual pair that is going to be the two things that are asserted to be equal. And it'll return a true or a false if they are matching or if they are not. This third element here is just some friendly commentary that you can add into your assert equals so that when things fail, it will return that, and you can get a clue as to what should have happened or perhaps what might need to be fixed. And so if we were to look at the debug log for line 40, well, actually, I don't need my debug log. I'm going to have to scroll through this because the system asserts do not appear there. We can see that it does acknowledge that, and it just pretty much glides right over it because it all worked out. It doesn't actually tell us, in this case, that anything went wrong. If they hadn't been equal, we would have gotten a message to that effect. Which brings us to your next chance to get your fingers dirty on the keyboard. We're now going to try and identify where in our phrase the string less occurs. So your assignment is to count the indexes, put in where you expect it to occur in that first, and replace that first null with your expected number. And then here in the actual place, we're going to put in the result of our index of less method. So I'll start with the thing I know, which is that I want to get the value of number 5. But now I need to go over and actually count, where does less occur?
Wasn't it 8?
Let's find out. I'm setting myself up to fail here. So I counted, and oh, it's the 9th character, so I put in 9. And if I run my test, I can automatically see here in the log that it's saying the assertion failed. And if I look on the test tab, I can also see that I got an unfriendly red X rather than a friendly green check. If I double click on that, I can see more information, and it's telling me, well, you expected 9, but the actual value is 8. And it tells me where it found that. So now at this point, if I were writing this, I have two questions to ask. I could say, well, maybe I just should have expected an 8, and that's what I should have put in that first place. Or I can say, I really needed that to be 9, not 8. Maybe I got it wrong. And maybe what I'm really needing to do is go, it's not my expectation that's wrong, it's my code. I actually wanted to get the index of ESS. And if I make that change and run my test, I get a pretty green checkbox telling me I got it right. So the thing to be careful of when you get into unit testing is making sure that whether it's your expectations or the actual code that is wrong. It's easy to write unit tests that will pass, but sometimes that's not good. You need to write unit tests that really are testing your expectations as well as getting the actual result you want. All right, so we've already been working with numbers quite a bit up to this point, generating them out of our strings, but let's get into some pure math. So I'm going to start here and just give us a couple of integers to work with. And I assign the value of 6 and 7 to the integers called number 6 and number 7. Should be easy to keep track of. And whereas before we were using the plus to concatenate strings, here the plus operates the way we really are used to it operating, which is to add a couple of numbers. And it's simply going to add number 6 and number 7. Yeah, and we can guess it's probably going to get 13. And if we were to check our system debug here, we would get number 13 out of that. But now we want to take a look at that other curious operator that we took a look at, and that's the incrementing operator. So you can see that here I'm starting with that integer called sum1, and I'm using that increment operator after the sum1. And then a couple lines later, I'm putting that increment before sum1. And this is a case where the placement of this particular operator really makes a big difference in what happens. That increment operator is doing two things. In fact, as operators go, the plus plus is almost more of a method because it's really taking an argument, which is our variable here, doing something with that and returning a value. But the big difference in the location of it is which of those two functions it does and in what order. So it has to increment it and it has to return the value. Or it has to return the value and then increment it. So if we take a look over this, we can see we first start here with sum1 and then the plus plus incrementer. And then a couple lines later, we have plus plus sum1. Let's look at how that played out in our log. So what we can see here is we started with the value of 13. The first time we used it, we did it afterwards. So we have x and then plus plus. And even though that number was incremented, the first thing it does is it returns the original value, 13. Now, in the meantime, after it's returned that value of 13, it actually did go ahead and increment it for us. So on the next line, we said, well, what is the value now? And now it's actually gone to 14. Then on the next line, we had put the plus plus before our sum1 variable. And when we do that, the first thing it does is it increments the original number, and then it returns the value. So in this case, it took the 14, added 1 to it, and then returns 15. Once we start working a little more with particularly for loops, we'll start using this incrementer, and you'll see that it really can make a big difference in your code, which side of your variable you are placing that incrementer on. Now, to give you a chance to practice with that a little bit, we've got a couple of lines here for 58 and 59, where we are going to first recreate our sum by adding those numbers, and then you are going to increment that, and finally you are going to fix this assert equals with the expected value and run your test and see if the test passes or if it fails. So go ahead and give that a try. So this one was a bit of a trick question, because what we would expect is, well, I started with 13, and then I did this incrementer, and that should have changed it to 14 for sum 3. Well, what's actually happening here is that we're calling sum 3 in our assert equals, and it's at that point that it interprets the sum 3. And so as we saw just a few lines before, if we put the plus plus afterwards, first thing it does is it returns sum 2, and then and only then does it increment it. So at this point, the way I have line 59 written, this is still only 13, because it's just going to return sum 2 and then increment it afterwards. And if I save this and run my test, it passes. Or I could say, well, maybe I really did expect this to be 14, in which case I needed to write my incrementer that way so that first it increments it and then it returns the new value.
Look, if I may just stop for a second.
Go right ahead.
If you find this confusing, don't feel bad. The idea here is when you do an assignment from one variable to another, basically you're saying take whatever was in sum 2, whatever is returned from that whatever is on the right side of this of the equal sign, whatever is returned by that, put it into sum 3. Now, because, as Luke said, the plus plus after the sum 2 means first it does a return and only then increment, then it first returned sum 2 as it was, which was 13, assigned it to sum 3, and only then incremented sum 2. So in this case, after line 59, sum 3 will be equal, in the first scenario where the plus plus was after the sum 2, after line 59, sum 3 would have been 13 and sum 2 would have been 14. once Luke moved the plus plus to the left side, it first increments it and returns it with the increment. And again, if you find this confusing, don't worry about it too much. It will, as you start practicing it and using it, it will definitely set in and will become a lot more easier to understand.
Thank you, Ohad. All right, so up till now, we've really just been working with integers, nice whole numbers. But pretty quickly, we're going to need to be working with fractions and decimals. And this is where we have to start being aware of the different data types. So if I declare an integer, and I'm going to call it decimal 0 because I'm sort of expecting that if I divide 6 by 7, I'm going to get some decimal value. But what actually happens is that Apex says, well, you're dividing an integer by another integer. Since I'm only working with integers here, I'm going to give you another integer back. And if we were to look at our log on line 63 or 64 where I did the debug, even though we know 6 divided by 7 isn't 0, that's just how it's going to interpret it. It's going to say, well, I can't give you whatever 0.833. It's not an integer, so it's just going to round that down to 0 and return that. And even if we say, well, all right, then I'm going to call this a decimal because that's what I want. Here I called it an integer, so I must need a decimal. And I do the same thing, it's still going to return 0 on line 68. Because still we're dividing two integers and it's interpreting the result of two integers divided as another integer. So if we need to be converting from one data type to another, we have a couple techniques for doing this. One of the ones that I didn't encounter for the first few years in writing Apex that was such an aha moment was this convenient notion of casting. So I basically take the same phrase I had on line 67, but I put in parentheses the data type that I want this to be treated as. So I wanted to treat the integer 6 as a decimal, and I wanted to treat the integer 7 as a decimal. And now I have two decimals being divided by one another. And if I look over here at the debug line, we can see that I actually get the decimal return value that I really wanted. Now that's very handy when we already have a number assigned to this as 6, but what if I need to tell Apex that a number is starting as a decimal? And here I'm going to jump to a similar data type concept, the double, which if you recall from Ohad's presentation, a double is just an extra big decimal. We can pretty much use them interchangeably. We don't have to be too sensitive to memory consumption. So here, I sort of set up the same scenario I had before where I am dividing two integers. How do we know these are integers? Well, they don't have a decimal point after them. And just as we saw before, if I'm just dividing two integers, it's going to return another integer, and it's going to give me 0 again. Actually, no, in this case 1, because 5 divided by 3 comes out to 1. Now, it does do me the kindness of at least turning it into a decimal, but it says it's 1.0, so still not so helpful. Not really the answer. But I can inform Apex that these numbers are to be treated as decimals or doubles by adding 0.0 after each one. Mathematically, they're equivalent. But the way that Apex interprets this is, oh, you must want decimals. And so if I look over at my return for line 78, we are now getting really the value that we were seeking. And similarly, with integers and long values, we get some funky behavior if we don't define our data types correctly, even just when we're adding the number. So here I add the largest possible integer value, and I'm going to add 1 to it. Well, that should come out to be, 2 billion something 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 and 8. And when I add 1 to it, we get a really unexpected result. It makes it negative. And that has to do with how this particular language and most languages treat integers and the maximum value. It loops it around to the negative side. And as you can imagine, if you were trying to do calculations, that would really throw off your accountants. So the way to overcome that particular scenario is with a rather unexpected annotation at the end of your integer, and that is a capital L, which tells it that this number that looks like an integer is actually a long and can be a lot bigger. And now here we get, there we go, it stayed positive and it added 1 to it. So these last couple examples here, I didn't add any fix me statements because these are not things you're probably going to be working with as much, but I bring them in front of you so that if you're looking at others' code out there on the interwebs and you see this, you see an L at the end of an integer, you can think back and go, I saw that before. I know that does something funky. And you can go off and hopefully get a quick answer on that. So it is 9 o'clock, and I know I had said this would be 2 hours. And if you don't have the time to stick around for a quick lesson on dates and times, I'll certainly understand. But if you can stick around, we'll take a quick look at the last of what I would call the simple primitive data types. And these are the date time, and time data types. And these are probably the closest to what we work with in formulas and workflows and the functions that are provided there. We certainly have the today function in formulas and workflows. And for date times, we have now. And I think, and I haven't checked this in a while since I haven't been in the formula editor, I think we can even assign specific dates and date times with functions there, if not just putting them in the correct format. However, for creating them directly in Apex, such as this example with time, we end up needing to give it a pretty specific format. And I can tell you now that even doing this for 6 years, I never remember this format. And so whenever I have to provide a very specific date or date time or just time, I am always heading right off to Google and Googling Apex time methods. And as you can see from my returns and the color of the links there, I have frequently gone off to visit these documentation pages so that I can remind myself, how do I set a time? Oh yeah, I have to use this new instance. What do I put in there? Oh, okay, it takes 4 arguments. I have to give it a value for the hour, and the minutes, the seconds, and the milliseconds. And it's going to look something like that. So You can definitely count on getting used to Googling these and using reminding yourself on the fly how to write these. Now, up till now, we really looked at just using one method at a time. But we can also start to string or chain multiple methods together. So here, I want to set a time data type, and I give it a name of time2. And I start with a date time data type, and I say date time now. And that's going to return the entire date plus the time. So Wednesday, July 13th, 2016, 9:06 p.m. But all I really care about is the time. So after I call my now method, I can then use another dot in my dot notation and add in that time method. And it will extract just the time from, did I do a debug on that? Nope, I need to uncheck my debug, find time2, and it gives me, well, it gives me somewhat unfriendly version. That's because this is similar to that new instance. It's dividing it into the computer, the digitized version of the time here. Not so friendly, but nevertheless accurate. And then the other thing that we can do, and this is again similar to formulas, is we can use basic math operators on our date and date time fields. So date 1, that was the variable I declared as today. And if I add 1 to it, well, it's going to make that tomorrow. Oh, and there is one final fix me here. Your final assignment on this is to create the formula that would return the date of yesterday. There's actually a couple ways we could do this. I could, of course, start with today and subtract 1 from it. Or, nope, it's saying I have a problem. I think I probably need to do this as a new variable here. So we'll call this date 3. Now I could do date 1 minus 1, or I could even do date 2 minus 2 and go to 2 days before tomorrow, and then get throw my date 3 value in there. And if we take a look at our debug here, we can see that I did indeed get yesterday by just subtracting 1 from today, or subtracting 2 from tomorrow. So there you have it. There are the basic data types, as well as a introduction to the documentation and how to read it. And we will be advancing on using all of these concepts in our future sessions. And certainly take some time with Trailhead and start working your way through the Apex lessons there, because these sessions are really intended to accompany the Trailhead by kind of filling in the gaps in what Trailhead and the documentation doesn't teach. And those gaps are, those little tricks like casting, or how to make debugging easier, as well as what it means if you put the incrementer before or after your variable. All those things that I kind of painfully learned over many years, and hopefully I'm helping you accelerate through. I'll be sending out a follow-up email with all of the links that we looked at tonight and other resources that are related to the topics we covered. And we will have our next session in 2 weeks. Everybody who registered for this will automatically get an email informing you of that next session. Even if you can't make it, go ahead and register, and that way you'll get the email that will have the link to the recording, as well as an invitation to the one after that. So I guess before we close off here, are there any final questions? If so, go ahead and drop a chat into us, and we'll either answer you directly or get that answer out to everybody if it's something that everybody would benefit by. Again, I would like to thank my co-presenters here, Ohad and Tom and Shiv, and who was number 4? I had a 4th one in here. Jonathan, right. Yes, thank you. Thank you all. As I look back through the comments, I see just how busy you all were while I was here nattering away. So a big thank you to them for answering all of those questions. And of course, if you come up with any other questions, you can take a look for my email address, which was in the invitation and the subsequent follow-up emails, and hit us with those questions there. Rachel asks, do you have Apex exercises we can practice? This is where I would direct you to either look at Trailhead for some Apex practice, or also the Apex workbooks, which have been around for quite a while. And those will really give you some similar and related exercises that will really add value to what we covered here tonight, and hopefully give you a bigger perspective on Apex development. And of course, in future sessions, there will be more Apex exercises to practice on. So thank you everyone for joining us tonight, and certainly spread the word if there are others out there who are eager to learn this. We have room for many more in our sessions here. Thanks everyone, and I'll talk to you again in 2 weeks.